Okay, question 1. I might do the first 5 multiple choice, I think it is, and then we'll go backwards. We'll start at the end and start with the harder questions and see how we're going from there. So at least we get an opportunity to do some of the harder questions. If p of x is equal to x cubed plus 4x squared plus x minus 6 equals 0, which of the following is a factor? Pretty straightforward. You're just going to sub in 3, sub in 2, sub in minus 1, sub in 1. You guys, I'm sure, have worked it out for question 1.
I'll leave multiple choice to do.
Nice. C?
No, A.
A. 1 worked. 1 plus 4 plus 1 is 6. 6 take away 6 is 0. I like it. Done. Easy. Question 1. Yeah, well, anyone have any questions? No, I didn't think so. If x minus 2 in absolute values is less than 6, which of the following is true? If you're doing it your school's way, you probably would be writing something like this. And then it's pretty easy. That means you've memorized this. Minus 4 less than x less than 8. That's great. But if you haven't memorized these, which is not my way, what we would usually do is just go x minus 2 equals 6, and then x minus 2 equals minus 6, x equals 8, x equals negative 4. So we draw on a number line, negative 4 and 8. Test. We're going to test x equals 0. 0 take away 2 is negative 2. Absolute value of negative 2 is positive 2. Is 2 less than 6? 0 worked. That means they're going to meet. So the answer is negative 4, less than x, less than 8. Whichever one. The only reason why I've obviously taught you guys this method is because this works for every question. This method only works for this specific question. So up to you, whatever you want. Any questions? Number 3, the number of ways the letters, and by the way, I'm working fast, but you guys got to start to learn to work fast as well, because you've only got an hour and a half to finish the paper. So we've got to think quickly. The number of ways the letters from the word noon can be arranged is, obviously that would be 4 factorial over 2 factorial, 2 factorial, the repetitions of n and o and o. So what's the answer to that? 4, 12, 24 on 4. I think it's 6, if my math is not wrong. I'm sure someone can tell us if it's wrong. Okay, any questions there? No? Let's get the next one. Question 4. Carl brews his own beer in a barrel. From past experience, he knows that the amount of sugar that is present in liquid kept at a constant temperature after 10 minutes satisfies this equation, which is always the same equation. M0 just means initial mass. So you can think of it like that, or you can think of it as like this. Doesn't really matter. It's just a constant. Where K is a constant as well. He places 20 kilograms of sugar, that means M, in a barrel for his brew. After 20 minutes, so when T equals 20, he finds that only half of the sugar is left in the brew. He realizes that M equals 10. The value of K to 3 decimal places is, okay, what's our step 1? If you guys are used to this by now, you would know what step 1 is. Anyone?
Use T equal to 0.
Yeah, T equals to 0, M equals to 20. So initially, you got to always find your initial values. So initially, you know that the mass is 20 kilograms. So when T is 0, M equals 20. So you're going to get pretty much M0. E to the 0, which is just 1. So therefore, M0 is 20. So now your new equation is 20 EKT. Then your second step is always to sub in the second condition. That's when M is 10 and T is 20. And then pretty straightforward solution to find K. Hopefully we're used to it by now. Divide 20. Now you've got E 20K. You're going to log both sides. And then you're going to divide by 20. So essentially, K equals log 0.5 on 20. Someone give me an answer for that? Log 0.5 over 20. B. Are we happy with B, everybody?
I got D.
D.
Yeah, I got D as well.
I think log 0.5 is negative, so then that should have been a negative, but just check it again in your calculator. What happened? Unless you had a negative one in front of this for some reason when you're working out. Emily, let me have a quick look. You look. You did 10. Ah, okay. Yes. 10 on 20. Left on right. Yep. 10 on 20. And then over 20. How bad would that be? So just so everybody can see something, we had someone that just did this, which is, a simple mistake. 20 on 10 and then on 20 and everything like that. Obviously, if the answer came out, it became B. What a waste of time. You'll get 0. All this working out for nothing, which is sad, obviously. So that's why I usually do say multiple choice. They're not usually they're obviously worth a mark, but the working out is sometimes not worth a mark. And if you end up getting it wrong like that and not going back and checking, you just wasted a lot of time for nothing. It's sad. But of course, firstly, you shouldn't be making those mistakes. Question 5. Which expression is equivalent to cos plus sin? Oh, that's for those who are in the Thursday class, you probably just remember this. We went through a little bit of that. Cos plus sin is cos
A minus B.
A minus B. Yeah, because it's plus already. So then cos 3x minus x. Nice and easy. Finish it off. Answer's D. Very good. Next one. Any questions? Again, I hope those who were in their Thursday class are realizing it's a lot easier now, let's say, doing these exams. You can't keep waiting for me. You guys have just got to remember that. Sam won't always get the time to revise. You have to revise for yourself. Cartesian equation. What does that mean? What does find the Cartesian equation mean? T. Can you tell me what specifically Cartesian equation just means? You're saying solve for t, which I think you know the method. Anyone know what Cartesian equation means compared to the parametric equations? Or what
Isn't Cartesian just x and y?
Yeah, only x and y. So pretty much no t's, no parameters. No parameters. So no theta and no t or q or r or s, whatever letter they use. Those are usually the letters we use for parametrics. If it was theta, you probably need to use this. If it was theta, you'd probably use this identity. If it was T, Q, R, and S, then the easy questions I usually make T the subject and then sub it into the Y value. I did a nice one with my U12s the other day, which I like to give to you guys. So 2x on 3 minus 6, and that's it. That's an equation with x's and y's. If you want to take this upper level, let's see if you guys can solve this one. Okay, x equals t plus 1 on t. Y equals t minus 1 on t. I gave them that. No one was able to do it. But let's see. You guys are in year 11, maybe a little bit more fresh for you compared to those guys. I'll give you a clue so you don't just start doing it. You can't make t the subject. It won't work like that.
Would you make common denominator for both?
I like it. At least she starts something. Here we go. And here you go.
And then if you times by t to the other side, you have, and then bring it over, you have quadratic.
Yep, let's just keep seeing what she's saying. T squared plus 1, yt equals t squared minus 1. Now what? You'll get a quadratic like you're saying, t squared minus xt plus 1. and t squared minus yt minus 1.
And then you make them equal each other, and then I don't know.
I like
lost
it,
myself.
but are you going to be able to get rid of the t? Look what's going to happen. Make it equal to each other. You're on the right track, right? Like it might work for another question. The problem is, can you see you're going to still have t? So I'm not going to take that away from you. You've done a good job. The problem is you're still going to have t. You haven't been able to eliminate t. But I like your thinking. Like, it might work for another question. Unfortunately, it doesn't work for this question because you won't be able to eliminate t. So good try. Don't stop doing that. It's fine, but not going to work. Okay. Anyone else? Don't just keep looking at it, because looking at it is not going to do nothing. Think of things to do. Just say things. Just like she said common denominator, and we tried and it didn't work out. Something else. Be creative. Especially you guys that have been doing extension 2, you should already know some creative ways of doing
Plus 1 minus 1.
There you go, like plus 1 minus 1. Again, it could work. It's not going to work in this case. Or unless you know what to do with that plus 1 minus 1. But I'm just going to say it's not going to work. But that method will work. I just don't think you guys know how to use it. So I can't accept that. Give me something else. Just be creative. Think of everything you've ever done in your life. It's not. You have to specifically do something to both sides. Nope, not going to be t formula. Don't bring trig in. You got to do something to both sides. Just tell me what are we allowed to do to both sides? Just randomly. Random.
Can you bring the t up to the top?
Say that again. Bring t to the top again. Yes, but it's not going to do nothing. Like you change it to index laws, it's great, but where is that going to go? Nowhere. Both sides. I'm saying. I'm trying to
Would
get
you
guys...
square both sides?
Okay, there we go. Let's square both sides. I said creative. All right, square both sides. Well, what's going to happen? Think about it. Forecast it right now. Now that you said square both sides, think of the expansion of these two and now multiply them. Well, t times 1 on t is 1. But then what do you get? You get a common factor of t squared and 1 on t squared. Don't you? Minus 2, because this and this cancels out when you multiply. And then, look, plus. You've made them the same again. The fact that there were one was a plus, one was a minus was annoying, but when you square it, what happens? Plus 1 on t squared, plus 1, oh, that should be t squared. You guys can see it. Now, that and that is the same as that and that. Now you can do a simple substitution. Yeah. And see, that's not something that can be taught. Like you can't specifically, I can't teach every question in the world. Or you can't expose yourself to every question in the world. But what you've got to do, you've got to think about it in the exam paper and go, okay, I got to get rid of t. Let's start being creative. The first technique that we tried was a good technique. Common denominator, make t the subject, unfortunately, it didn't work for this question. But squaring it now, I know you all will remember this, should make sense. And the logic comes from this guy here. Sine squared plus cos squared also equals to 1. So anyways, once you square it, I think we can see you get y squared plus 2 is t squared plus 1 on t squared. Substitute it in here. X squared equals y squared plus 2 plus 1. And you're done. That's it. X squared equals y squared plus 3. But you have to learn to be creative. Like I said, I can't emphasize that anymore. You have to learn that skill. Be creative. It's okay. Square both sides more than square root both sides. Plus 1 minus 1 would have worked if you said plus, let's say, yeah, like I said, plus 1 here so that you can get a perfect square. And then minus 1 to balance it. So that would have worked, but like I said, you really have to know what you're doing. Oh, why don't I write plus 2 here? Ugh. Plus 2. That should be plus 2. And that should be 4. Is that better? t squared 2 times the inside, and then 1 on t squared. T squared 2 times the inside, yeah, that's better. And then y squared plus 2, yep, y squared plus 4. Okay. All right, there you go. Any questions? The one you'll most likely get would be stage 1, would be this one. Stage 2 would be the theta cases. And this is like, if you just want to get Sam's questions and be annoying like I am, then that would be stage 3. But you know, you don't know, maybe in your exam they might do that. It's more just, I like to test that skill, teach you guys, be creative. Because if you want to get to the state ranking level, you really have to be creative for those last questions. Okay, I'm going to scroll down. Like I said, I want to start backwards. So let's see what is happening back here. All right, let's start question 19. That's the last one. Oh, I know, look, it works well with the question we had on Monday. A polynomial has a double root. Can someone tell us what a double root? Differentiation. I like that. So that means you can start teaching it. You know, when you start knowing what to do without reading too much into it, you really are ready for it. But anyways, differentiation. What else? What does it mean in terms of x minus 7 to the power of?
2.
Squared to the power of 2. So double root means, obviously, it's got 2 roots at the same place. So it means 2 things. It means that p of 7 is a root and p dash of 7 is a root. So they're both equal to 0. And like I said, in terms of factors, that's what it looks like. Anyone have any questions about that? It says write an expression for the polynomial. So you're not sure if it's a cubic or if it's a quartic or if it's a power of 5 or power of 2 or anything like that. So you have to make it very generic. How would you write a polynomial that is generic? For this. Anyone help us out?
What if it's the power of n instead of
X minus 7 to the power of n.
He said that as well. That's interesting. It's not. It's not power of n. You specifically know it's a double root. So it's x minus 7 to the power of
2.
2. But you guys that are assuming it's this, you're assuming that it is, let's just say the polynomial can be a double root, a triple root, or whatever. But you're also assuming something worse than that. You're assuming this is the only root. Who said this is the only root? What if it was like x plus 1, x, everything else? So it's definitely this multiplied by
C. Or would it be plus
we don't
C?
really write c. It has to be a function in terms of,
Is it Q of X?
yeah, like that, or a of x. We usually use a of x, but you could have used q, who cares? It's all the same letter. So it's multiplied by something else with x's. Now x could have been 0, so it's a constant. It could have been, you know, a line. It could have been a quadratic. It could have been anything else. So it's just as long as this is a factor, plus
ax plus b remaining?
you don't need to write ax plus b.
It's going to be plus 0 because it's a factor.
No, incorrect.
B.
Again, you're assuming that it's just
R of x.
r of x. That's the one. So what's the general form of your polynomial? You know, it doesn't matter the letters so much, but it's a function in terms of x multiplied by another function in terms of x plus any remaining in terms of x. That's how it works. So polynomials, any 2 factors multiplied plus any remaining. If you didn't write r of x, if you wrote ax plus b, if you chose ax plus b because you know that it's going to be 1 power less, then you have, again, assumed that it's only a double root. But you don't know because you don't know what else it's being multiplied by. That's why we're going to write r of x. So does that make sense? So if you guys think of your polynomials, one more time. If I had x minus 1, x plus 2, x minus 3, so you wrote them as products of each other. If there was nothing remaining, great, nothing remaining, plus 0. If there was a remainder, you would have written plus 5. So it's the expansion of these brackets plus a remainder of 5. And that's exactly how we've got to write it up here. All right. I can almost guarantee, so I can't say 100%, but I can almost guarantee you will get this in your exam this year. If you don't get it in your exam this year, it will be in your trial HSC or in your half yearly or something like that. So 100% you will see this question, A and B. I can't guarantee that it's going to be this year, but it will be, if it's not year 11, then you'll see it in your year 12 exam. The reason why it'll be in your exam is because everybody does the derivative wrong. So that one's easy. I mean, most students get that out eventually. It's the derivative bit, part B, that's worth 3 marks and why it's at the end of the paper. A lot of students get the derivative wrong. So let's do P of 7. Now that we have our little, what do you call it, function, P of 7 equals 7 take away 7 squared A 7 plus R 7, which equals to 0 plus R remainder of 7. But will you have a remainder when you supplement in 7 if it's a root?
No.
No, but R7 equals 0 since 7 is a root, which equals to 0. That's what I mean, that, because it's very theoretical, a lot of students don't get it fully correct. Oh, that's fine, but again, most can get that out and they can fudge it out. It's the next one, P dash. So let's get P dash of X first. Does anyone actually know how to differentiate this? There's a word I'm looking for.
Chain rule?
Chain rule, no, that's not the word that's important. You'll probably use that. That's not the problem. Anyone know what you specifically need to do or use for this? And if the answer is no to everybody, then at least we found a
Product rule.
Oh, there we go. You got it. It is actually product rule. Why, Anouk?
Because you got x minus 7 squared times a of x.
Yeah, you got two functions in terms of x's. If there's two things that are multiplied and they're x's to differentiate, you must use product rule. Here we go. 2 x minus 7 times a of x plus v dash, the derivative of ax, we just write a dash x, just like you write p dash x. So a dash x times u plus r dash x. At this stage, wait, firstly, any questions? Everyone have a look at them. U dash v plus v dash u plus, and then obviously r dash x. Any questions? No? We're happy? We can execute that. At this stage, you can obviously sub in 7, because why not? But I want to take you guys up one extra level and show you why it's a root at p dash, right? Like why this actually works, this concept of if it's a double root, why the derivative is also equal to 0. So look what happens. If I factorize x minus 7 here, if I factorize x minus 7, I'm left with 2a of x plus a dash of x plus obviously r dash of x. And then the idea is, as you guys can see now, if I had my polynomial a power of 2, then if I differentiate it, I'm going to have a power of 1. And that works for all of them. If I had a power of 3, well, that means the derivative is going to have a power of 2. The second derivative will have a power of 1. And that's where we got the logic from. Obviously, p dash of 7, 7 take away 7 is 0, plus r dash of 7, but obviously r7 was already a 0, so the derivative of 0 is still 0. But r7 was equal to 0, so r dash 7 is obviously equal to 0. Therefore, p7 equals p dash 7 equals 0. This came from the extension 2 course. So, for example, those students who were doing extension 2, let's say in the previous syllabus, all they had to do was literally memorize this format, and they would have got 3 marks in their extension 2 paper. So it wasn't hard. It's just that there was that trick with the product rule that you need to obviously be aware of. So because it was extension 2, it gets dropped down as a hard extension 1 question now. But to me, it's pretty straightforward. You follow the rules. They don't really change too much. Okay, any questions?
Why did
Yes.
the x minus 7 disappear when you factorize?
Sorry. It's because I knew it doesn't matter. But again, I did a mistake. Sorry, man. Good eyes. There we go. So factorize, I get 2ax plus a dash and then x minus 7 still. But it doesn't matter once you sub it in 0, but you're right. I should have not missed that. Thank you. Any other questions? Okay, let's go up. Question 18. Find the exact value. It says find. It doesn't say prove. So what are we allowed to do? Wait. What do we, I just want to make sure that we get, because we said something on Thursday when we did inverse, and I just want to show, like, what are we allowed to do first? Like when he says just find the exact value. Just
Put it in
plug
our
into our
calculator.
Yeah, but when you do that for this question, is it going to work? Try it out. I'm looking at the marks, and I'm just going to assume it's not going to work. So if it doesn't work, then unfortunately, you have to go back to your basics, which is let alpha equals, can someone tell me which one? Inverse tan, good job, the inverse. And then what do we do at this stage? Tan alpha or tan theta, it doesn't matter. Beautiful, okay, now pause. What are we trying to prove? Remember, I always write IE, this is what we're trying to get at. We're trying to get sine to what? Doesn't that sound familiar? Sine 2 alpha, sine 2 theta, what's that equal to? 2 sine alpha cos alpha. Well, then you remember from tan alpha, you can get your triangle, and then from there you should be able to get sine and cos, and then you've got 3 marks. Okay, alpha, opposite over adjacent, opposite over adjacent. This should be 2 plus 1 root 3. Did I do that right? 2 squared, root 2 squared is 2, 2 plus 1 is 3, I think so. Again, you guys will tell me if I'm wrong. Sine alpha, opposite over hypotenuse, cos alpha, adjacent over hypotenuse, and of course 2 times 1 on root 3 times root 2 on root 3, 2 root 2 on 3. Plug it into your calculator and hopefully it works to give you the same as the original one. So what we said on Thursdays, for finding questions, sweet, you can just sub it in. The problem is you can't always do that because it doesn't actually give you the exact value. For the ones that can, which is your most of your textbook questions, then great. But
Sam,
this
I
one,
plugged this one in the calculator and I got it.
you're 2 root 2 on 3.
Yeah, well, you get like a decimal, and then if you square it.
Square it, then square root it. Yeah, you're doing my trick. I know, I got it. But the problem with that is, imagine it was plus 1. Your squaring business won't work. So let's just make sure we can do it this way. Because if this was a cos 2, if it was exactly the same, if this was cos, then you'll get cos 2 alpha, which means you'll eventually end up with, like, let's say, one of them would be 2 cos squared minus 1. You have to sub in cos alpha. This might not exactly work out because of the minus. I don't know. Just saying, I don't want to risk it. So if it was changed, we might have problems. All good. Move on. Question 17. T formula. Again, I think Thursday class is right up your alley because we just literally did all this. But again, I told you guys on Thursday, I said your last questions are going to be triggered inverse trig. So Rosemary said it best. She said it's endless. And I think that's the idea with trig. They're endless. So it's really the part you want to focus on. All right, 1 plus sine minus cos. I'll leave you guys to do, just to start it off. I'll give you your triangle that you need for your t formula. There's theta, there's 2t, 1 minus, 1 plus. The only thing I'm going to say is please don't use the fraction. Unless you're really, really used to it and good at it, don't use the fraction, use your division sign. Good luck. I'll leave you guys with it for a minute. Okay, my turn. 1 plus sine theta, which is opposite over hypotenuse, minus cos theta, adjacent over hypotenuse, divided by 1 plus sine plus cos, adjacent over hypotenuse. Okay, common denominator, so we get 1 plus t squared plus 2t minus 1 plus t squared on 1 plus t squared, divide, same thing, 1 plus t squared plus 2t plus 1 minus t squared on 1 plus t squared. You're trying to get t, don't forget. So you kind of know the answer. It's got to become t. So t squared minus t squared is gone. 1 minus 1 is gone. You're left with 2t squared plus 2t on 1 plus t squared times, flip this, 1 plus t squared on 1 plus 1 is 2 plus 2t. And I think at this step, I usually just cross out and then factorize this as 2t, t plus 1. And then this factorizes to 2, t plus 1. You can pretty much cancel that, because you know the answer, and you just write equals to t. Equals tan theta on 2, and you can start here. We should start with LHS. So that's fine. All right, questions? So I pretty much smashed this last step. If you want me to do that a little bit slower, let me know. I'll rewrite it again.
Yes, please.
So we had 2t plus 2t squared, so 2t plus 2t squared on 1 plus t squared times, flip this, 2 plus 2t. At this stage, these two cross out. Next, I'm left with 2t plus 2t squared on 2 plus 2t. Next line, maybe now I would factorize t out. And I'm left with 2 plus 2t, 2 plus 2t, cross, cross, left with t. There you go. That's a bit of a different strategy than I did before. I factorized everything before, now I'll just factorize the t out. All good? Any questions? All right. Next one. Question 16. A bag contains 5 marbles of different colors. In how many ways can these 5 marbles be arranged in a line if the green ball must be first? The answer is 4 factorial. That was an easy one. Cross that, green is there. So then it's just 4 factorial left. Nope, no questions? Pretty easy. Yeah. Combinations, committee. A 10-person committee is to be formed from a group of 12 women and 16 men. How many ways can the committee be formed? If the committee must contain 5 men and 5 women, of course, what do you do? 12 choose 5 times 16 men, and you got to choose 5. Whatever that gives you. There must be at least 5 more women than men. Right, at least 5 more. So that means it can be 10 women, 9 women, 1 man, 2 women, 8 and 2 men. That's still 6, 7 women and 3. But that's not. That's 4 difference. So cross it out, and I think you guys know what I'm going to do. 10 women, that means you're going to go 12, choose 10, plus 12, choose 9, times 16, choose 1, plus 12, choose 8, times 16 men, choose 2. Any questions? No, we're good. Plug it into your calculator and we should get an answer of, anyone got it out? Emily's just doing it. Wait for you. For choose? Yeah. 4,201? Yeah, I don't know. No one's going to say nothing. I guess we'll have to accept your answer. Plug it into your calculator like that, it should hopefully get 4201. Anyone got a different answer?
Yeah, but mine's so big. So I don't know if I did it. Hold on, let me check.
Okay. All right. Let's go. I'm going to do it as well now. 12. Choose 10 plus 12. Choose 9 times 16. Choose 1 plus 12. Choose 8 times 16. Choose 2. 62,000.
Yeah, that's what I got. 62,986.
Let's see what you've done wrong. Did you get that second time? I wouldn't mind that. Seriously. Take your time. Okay. I'll just wait for you. Make sure you can get that. Got it? Done. All right. Question 14. Divide. Ah, easy. Go. Go, go. The only thing I'll raise, it's not for this question, but just be careful. If there was no x squared or x, please write 0x squared or 0x. Unless, again, you're good at it by now. You don't need it, but if you're not, write your zeros in there. This one doesn't need it. Go and divide. Okay. I'm going to try to do it synthetically, so without dividing, and see if we all get the same answer. 6x squared minus 3 equals minus 12 plus a. So a should equal to minus 3 plus 12, which is 9. And then 4 should equal to negative 18 plus b, so b equals to 22. And then minus 44 plus 40.
That's what I got.
Yeah.
Very nice.
Yeah.
There you go. That's how you can do it synthetically, for those who have been trying it synthetically. If not, whatever, you could do it the long one. It should still work out. Did it work out? Yeah. Okay, all good. Move on. Part B. Okay, you'll need A. Newton's laws of cooling. So the only difference between exponential growth and decay is the fact that in Newton's you've got plus S, the constant air temperature. It's all good. It's always the same part A. So Newton's laws of cooling states that a body cools according to this equation, where T is the temperature of the body at time T, S is the temperature of the surroundings. So as your surrounding air temperature, and K is a constant. Show that this satisfies the equation. What do we do? How do we show this satisfies the equation?
Differentiate.
Differentiate it. Derivative of S is gone. Derivative of AE negative KT becomes negative KAE negative KT. So you differentiate the negative KT, becomes negative K, and then you leave everything else an exponential. You've got to prove that it becomes T minus S. Obviously, you guys can see AE negative KT is T minus S. So all you got to write at this stage is T minus S. Done. 2 steps. Very straightforward. 100% will be in your exam. That's a no-brainer. So there's no reason why anyone should get that wrong. It's very straightforward. But anyone confused about any of the steps? Okay. Part B. Let's write down the equation so we don't forget it. T equals S plus AE negative KT. All right, all good. A still sphere has an initial temperature of 300 and cools to 175 in 12 minutes. The surrounding room temperature is 25. Find A. Okay, so when time is 0, temperature is 300. When time is 12, temperature is 175. And what's the surrounding room temperature again? The S value, right? The constant air temperature. S equals 25. Good luck. Let's see if you guys can find A. Usually start in S first and then your initial. Hopefully you'll get A, and then you'll probably use your second set of conditions to find K. Try to see if you can do both of them without much assistance from me. All right. Were you guys able to get it out? Got it out? A? Let's see. So T equals S plus AE negative KT. That's given, right? Straight away. You can substitute at least that in. Then I said, usually you're going to find A, just like your 11 advanced questions, by substituting your initial condition. So when temperature is 300, e to the 0. E to the 0 is 1. Therefore, A becomes 275. Then your new equation, that's A. But then we always like to write it like this. There it is. And obviously, how are you going to find K? How would you find K now? Your second set of conditions, time is 12, temperature is 175. You have in T, you should be able to find K. Maybe I should leave that with you guys for a little bit longer, try to see if you can get it out now. Temperature is 175, 25 plus 275, E, negative 12K. You know the answer, try to get it out. Simple. Subtract, divide, log, divide, we're done. Got it out. 175, like I said, the takeaway, 150, divide, 275. You would be at this stage. Subtract, divide, log both sides. You already know what the answer to this should be. I'm guessing it's going to be 6 on 11. It's in front of you. Negative 12, then you divide by negative 12, and you're done. Is there a part C? Is that it? No, that's it. All right. Any questions? All right. Next one. Let's go up. Question 12. Again, we literally did this on Thursday. Find the domain and sketch the graph. For the others who want a little bit of assistance, you'll need your original one. And that needs to just be memorized. You can't run away from it. So that's negative pi on 2 and pi on 2. Find your domain. Your domain is negative 1 to 1 for x. You substitute that in for x and you solve. That'll be your domain, and then the graph should be looking exactly the same, just new domain. Give you guys a minute again. Try that. Here we go. So -1 less than or equal to 2x, take away 2 less than or equal to 1. You just replace, right? Substitute plus 2 to everything. 1 less than or equal to 2x, less than or equal to 3, divide by 2. It's going to be between half and 1.5. And then just draw. There's a half. There's 1.5. It's obviously going to cut through where? At 1. You're starting at negative pi on 2, going all the way to pi on 2. Negative pi on 2, 2, pi on 2. There it is. Any questions? Easy. Question 11. We're getting there. I think we're pretty close to the beginning of the exam. So if I could get it done in about an hour or close to an hour, and teach it to you guys and wait for you guys, you can see that definitely you guys given an hour and a half, it's got to be done in an hour. If you're ready for the stuff, you're ready for the exam, you know what to do. Like let's say this question here, if I see sketch log, I already know how the shape works and what x plus 1 does. Come on. You can predict the questions. You know you're going to get an inverse sign. You know you're going to get a Newton's question. You know you're going to get this divide polynomial. So like, really, an hour for extension 1. That's your aim right now, you know. Now that you're practicing at home and stuff, you're doing papers, time them, get them done. You should not come back to me and say, I ran out of time. It shouldn't happen. You can fix it now. All right, I'll start with the first one, just to help everybody out. Y equals ln x looks like this. There's an asymptote here, cuts at 1. Voila. What does x plus 1 do? Shifts the whole thing to the left. So of course, your asymptote now is at -1, which you guys know because you can't log a 0 anyways. And then it's going to intercept at 0. And there it is. Nice and simple. Please try to do B and C. Absolute value and the reciprocal. 2 marks each.
Yes, did you see that there's no stationary points and stuff in the way?
Not meant to be. That's the thing. It's meant to be in year 12. But of course, if your school's taught it, that means it will be in year 11. And let's say our school might have done binomial. They'll do binomial in year 12. Or vice versa. It'll be binomial. You got a stationary point?
Yeah, we're going to put it in the
Yeah. Then you got a stationary point. So maybe you got to ask me those type of questions so I can go through them for you as well. When you're doing the HSC, when it says the 11, you probably won't see stationary points. So you would have to look at the in paper there, but there's, I think, in the middle of the paper, you see sub contamination. So do those questions. So you should be sticking with these 12 questions for stationary points.
Yeah.
Yeah, that's definitely useful.
At the end of the lesson, can you show like one quick content? Because I know how the basis can work. Thank you.
Okay, absolute value. Your vertical asymptotes obviously don't change. The bottoms lift up, flip up, and then that's a sharp point. And it looks something like that. And then one on, like I keep telling you guys, asymptotes, again, well, that doesn't change for vertical, but your intercepts become asymptotes as well. And then what's 1 over a very large negative number? 1 over a very large negative number. Very small positive number. No, wait, what? Positive?
Negative, the small negative.
Yeah, a very small negative number. You can't change the sign.
Positive, yeah.
1 over a very small negative number. Very large. Interesting. Okay, so it's going to do this. And then what? What do I do?
Doesn't go straight and stops at negative 1.
Stops at -1, open circle. Good. If you don't draw that, you're going to get 4 marks. So, you can't just stop at -1. It's an open circle because you can't include that, but because it's 1 over very large is very small, usually what we draw is stuff like this. Right? But because it's not going forever, it's stopping at -1, it's starting at -1 and then going down. So exactly the same shape, it's just that because you actually can't approach 0, it's going to look like this. And then of course the other one is straightforward. 1 over small is large, 1 over large is small. So that looks like your normal ones. There you go. Again, any questions? All right. Solve question 10, 3 marks. Please don't do it that squared business. Just do the critical methods. Right. Take another one. All right. Solve for x. First line, x cannot equal to 3. Multiply, 2 equals x minus 3. X equals 5. Number line, 3 is there, 5 is here. It cannot equal to 3. Open circle, it can equal to 5. Closed circle, test, x equals 0. 2 on -3. Is negative number bigger than 1? Obviously not, so they're not running away. Hopefully everybody got the same answer. 3 less than x less than or equal to 5. Happy with that? What would you do when it's absolute value of x minus 3? Well, nothing. You just do the same thing. X can equal to 3, you multiply your absolute value, so it'll look like this. And then this looks like something you've done 1,000 times before. X minus 3 equals to 2, X minus 3 equals minus 2. You'll get 3 different solutions. You got, I saw your face, you're like, but you can't do that. You gotta just do it the same way that you would normally do it, and it should work out. I'll leave that for you guys if you want to try it at your own time and then send me a solution. I'll tell you if it's right or wrong. But you might need to substitute a few different values to work out what's happening there. Question 9. 100% will be in your exam. Because you either know the formula and you'll get full marks, or you don't and you can't get it out. Can anyone help us out with this one? A squared plus B squared plus C squared. It's annoying that they didn't use alpha, beta, gamma, but anyways. A plus B plus C squared minus 2. ABC is incorrect. A plus B plus C is incorrect.
2AB,
AB.
2AC.
That one, yeah, two at a time. Sum of roots 2 at a time. AB plus AC plus BC. Good work. All right, go. Sum of roots. Okay, I think you guys can get this. Get it out. Tell me the answer, please, for that one, and then of course that one. Sum of roots 1 at a time. Product of roots. Subtract them. This one, oh, very easy. Very, very easy.
Yeah, what if you somehow wrote the formula wrong but got the question right? Would they take off the mark?
What if you wrote the formula wrong? You got the correct answer. It depends in the marking criteria. If your school's criteria for that question was correct answer, you'll get full marks. If it was correct solution, you won't get full marks. So in the HSC, we look at it as in terms of answers and solutions. If it's just an answer we're looking for, and we don't really care about the method. If it's a solution we're looking for, then yeah, the working out's important. If it's a transcript error, so for example, let's say this was a minus, and I used it as a plus, which very hard to get, but if it was the other way around, if it was a plus and you wrote it as a minus, that's called a transcript error. You haven't made it easier because minuses are meant to be harder than plussing. You'll still get full marks. Yes. So those ones, it's a transcript error, that's fine. But I guess you guys don't want to make those. A plus B plus C, 4. Minus B, C, minus D, minus 3 is 7. And then 4 squared minus 2 times 3 marks. How good is that? 4 squared minus 2 times minus B, C. Minus 2. 16 plus 4, 20 or something? Is that right? Yep. I like it that it's worth 3 marks, because I think the students who do get it, are the ones that obviously know the formula, so they're well deserved for 3.5. But it's a pretty easy one for 3.5, or whatever. Maybe 1 mark for the formula, 1 mark for the sum of roots 2 at a time, 1 mark for the answer. Maybe something like that. Oh well. All right. Looks like the last two, and we're done with this paper. Question 7 and question 8. Good luck. Okay, very easy. Here we go. Now, 2 methods again. Your school way would be to find your intercepts. And then you draw this, which is a parabola. And there's -3, and there's 2. And then because greater than 0, then it's this way, and it's this way. Which means x is less than -3, x is greater than 2. The way we've done it is always equal to 0, so we still end up with -3 and 2. Instead of that, we just test to keep everything uniform. Open circle, test 0, 0 won't work, so they're going to run away. Obviously, same answer. Any questions? Cubic. There's 2 ways about it, isn't it? There's the first way, which is, I'm guessing, what you guys would have all done, or most of you would have done, let's say. I don't know what you guys have done, which is that times that, maybe squared, or you just expanded those 2, and then once you got the expansion of these 2, you did it again. Can anyone tell me the way I would, like, that's probably, or it definitely wasn't the method that was taught to you when, let's say, this topic was introduced, but it's something that you can do now. What?
You use binomial.
Binomial. Yeah, well, why not? So now that you've ended year 11, you can put everything together and you're allowed to use anything at any stage. So like even axis of symmetry and vertex, you guys don't need to do the, oh no, that's going to be, but you can because you've done stationary point. So for example, if you had to find the vertex of something, you can just differentiate it, make it equal to 0, and that's your stationary point. So you don't need vertex and axis of symmetry anymore. That's gone. So, but anyways, yeah, I'm going to do a binomial. Here we go. For binomial, we need our coefficients, which is 1, 3, 3, 1. We get these by doing 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. And then you start off with the first one, cubed, plus 3 root 3 squared times 2, plus 3 root 3 times 2 squared, plus 1 times 2 cubed. So your root 3 decreases and your 2 starts to increase. And the answer should be 3 root 3 plus 3, not 3 times 3 is 9, 9 times 2 is 18, plus 4, 12 root 3, plus 8, and then you should end up with 15 root 3 plus 26, so therefore B equals 15 and A equals, nothing's stopping you doing it the other way. I just thought, since we're doing binomial, or we have been doing binomial, you might as well see it that way. All good? All right. So like in that paper, they didn't have any binomial and no stat points. So that means their school didn't finish it. All right. No questions? Let's close this up. I might actually save that for you guys and send it to you if you want to. Solutions. That's advanced math, which we're not going to be doing. Year 11 extension 1, exams, and send this across the